In this video we introduce Tangible Graph Builder, a tangible user interface that we have designed to investigate how best to provide access to simple graphs and charts to users who are blind or visually impaired. Current graph access technologies, such as pins pushed into corkboards or raised paper graphs, are cumbersome and cannot be integrated easily with electronic data. Technological solutions have been developed, such as interacting with a 3D graph model with a phantom haptic device, or using a sound graph. However, these solutions limit the natural two-handed exploration of the graph users employ. A tangible user interface can overcome these problems, providing the best of both worlds. Tangible Graph Builder allows users to physically explore and manipulate simple graphs. Users interact with a transparent tabletop. Ficons, or physical icons, are placed on the table and tracked by a high-definition webcam underneath. The tabletop is delineated into three parts using plastic tubes as physical guides. The tangible grid, a 9x7 grid containing the physical representation of the graph. The sonification strip, used to control a sonification of the graph in the tangible grid. The sonification control area, used to determine what, if any, data series should be sonified when interacting with the sonification strip. Users place ficons on the tangible grid to represent cardinal control points in the graph. The locations of these ficons are then connected by the computer to form data series. We use two different sets of ficons to allow up to two data series to be represented on the same graph. Lightweight polystyrene cones attached to a 4x4cm cardboard square, and hollow plastic cubes also attached to a 4x4cm cardboard square are used as the ficons. To further alter the haptic properties of the ficons, each cube is filled with 110 grams of plasticine. To allow for camera tracking, each ficon has a unique marker attached to the base, which is tracked using AR Toolkit technology. Whilst the grid allows detailed inspection, it is not so suitable to provide an overview of the data series. A sonification strip at the base of the grid, containing a special ficon, can be used to provide an auditory overview of each data series. As the sonification marker is moved between the major units of the x-axis, the value of each data series is calculated and presented as a musical note, the pitch of which is proportional to the current value of the appropriate data series. The sonification control area allows the user to determine which data series are sonified when the sonification strip ficon is moved. A user selects a data series by placing a ficon of the appropriate data set in the sonification control area. In cases where both data series are simultaneously sonified, a small delay is inserted between the playing of the note for each data series, and each note is also panned to a different speaker. In this example, we illustrate the sonification for the following graph containing two crossing data series. We have also modified Tangible Graph Builder to be suitable for browsing and constructing bar graphs. In this mode, each column represents a bar. A single ficon in the column indicates the top of a bar. Again, a pitch-based sonification is used, with one note per bar played as the sonification ficon is moved. In cases where the value of a bar is either not set or is set to 0, a unique sound is employed to indicate this. Also in this mode, there is only one data series, so the cone and cube ficons can be used interchangeably. In the following example, we represent this bar graph.